I'm going to continue the conversation about turn lanes and switch it over to the other side of the roadway as we go into right turn slip lanes or channelized right turn lanes. The project I'm going to be talking about was sponsored by TxDOT 06810, as you see up there, with the purpose of developing design guidelines for right turn slip lanes. My presentation is going to cover a little bit of the motivation behind the project, as well as some of the tasks completed to date. This is an ongoing project. We're nearing the final stages right now. Overall, the goal is developing the guidelines for inclusion in the TxDOT roadway design manual, as well as providing supplemental design standard drawings. We completed a literature review as well as focus group meetings whereby we invited TxDOT representatives, field and design personnel to provide input about the findings from the literature review, as well as support for development of the guidelines, which we've developed draft guidelines for at this point. I'll conclude with a summary of the findings, as well as some options for future research. So with right turn slip lanes, we're talking about right turn lanes that are divided by a channelizing island from the through movement. Sometimes they include auxiliary lanes, decel or acceleration lanes. They also have pedestrian facilities as well as other traffic control devices within the turning roadway. As far as the motivation, generally this stems from some inconsistencies in the design and implementation of these facilities, as well as some safety concerns, in particular with respect to other users or non-motor vehicle operators, with a focus on pedestrian safety at the crossing within the turning roadway. I'll also touch on some of the research, both recently completed and ongoing, that was also part of the motivation for this project, including a number of NCHRP projects, specifically Project 372, which included a survey on state of the practice among state agencies throughout the country with respect to these facilities, as well as NCHRP Project 389, which was developing sample guidelines for these facilities, as well as some safety models looking at some of the safety of these facilities, primarily with respect to channelized right turn lanes versus standard right turn lanes and shared through right facilities. We also looked at other reports, other NCHRP reports, other research done around the country as well as around the world. We also looked at other standards and guidelines developed by other agencies and looked at some relevant findings or guidance provided in current TxDOT documentation, including the TMU TCD, the roadway design manual, and standard drawings. Throughout this process, we developed an identification of some specific design elements worthy of consideration in the development of these guidelines. This is some standard drawings from PED 12A Design Division standard that you may be familiar with, that includes some of the pedestrian facility relevant to the right turn slip lanes, including the ped ramps for islands and medians. And then on the standard, we also see sort of a generic layout of a right turn slip lane with the pedestrian facilities included. As far as some of the notable findings from the literature review, first and foremost are the benefits associated with right turn slip lanes. There are a number of benefits associated with them with respect to the operation of motor vehicles, but also with respect to the safety, largely the improvement in safety with respect to the standard right turn lane, so where we don't have the channelization. So with respect to motor vehicle operation, generally this design is safer than some of the other design layouts, but there is that concern with the pedestrian crossing, primarily with respect to the fact that as we improve mobility of the right turn, we're increasing vehicle speeds through the turning roadway, and that can be a problem with respect to pedestrian crossings within them. Some of the research had identified pedestrian thresholds for consideration of supplemental treatments beyond just standard pavement markings, so we looked at a little bit of that as well. And then just kind of reiterating the fact that there are a lot of inconsistencies with the implementation and the design of these facilities throughout the country. As I mentioned in the process, we developed a number of design elements for consideration as we developed these guidelines. As you can see there, starting out with geometric elements with respect to the roadway, the turning roadway, including the angle of entry to the cross street, the pavement width, curb radii, the use of auxiliary lanes, the placement of drainage features, sign and pole placement to avoid pedestrian walkways, as well as the crosswalk and the location of the crosswalk and orientation, as well as some of the other traffic control devices within these facilities. Going into some of the traffic control, we looked at the crosswalk pavement markings themselves. Typically, these facilities use only the transverse pavement markings that we see at the top there. These are what you would commonly see around Texas if you see these facilities. They provide benefits for pedestrians as far as wayfinding is concerned. There's some information about the benefit for pedestrians who aren't blind but have vision disabilities in terms of wayfinding as they cross the roadway. In terms of the longitudinal markings, those have been suggested as a supplement or to be provided at these crossings for their benefit in terms of visibility on behalf of approaching motorists, so they're easier to see than the transverse markings. In addition, we have other supplemental devices that can be used, including additional pavement markings such as yield lines, additional signing at these locations as well. And then we have some of the other devices, including pedestrian activated beacons or hybrid beacons. We have the rectangular rapid flashing beacons, and then some of the other treatments as well, like raised crosswalks, the implementation of sound strips or rumble strips to help alert the driver of an approaching crossing. There's generally been a push by the Federal Highway Administration to move away from large sweeping right turns at these facilities and move more toward a higher angle of intersection with the cross street. In addition, AASHTO's recommended narrowing the turning path of the roadway to try to help limit some of the speeds for these facilities. In addition to lowering the speeds, increasing that angle of entry with the cross street puts the crossing for pedestrians more in the direct line of sight of the approaching motorists. It also decreases the head turning required on behalf of the motorists as they look to spot gaps in oncoming cross-street traffic. That's motivated some of the designs implemented by other agencies around the country. This is from the Maryland State Highway Administration, where they've implemented more of a sharper angle with the cross street. As you can see there, they've also implemented the longitudinal pavement markings for all crossings here. You see the compound curb radius for the turn to help facilitate the turning radius of the larger vehicles. We have movement of the crossing towards the middle of the channelizing island, which allows for some storage space downstream of the crossing for smaller vehicles. You may notice the perpendicular orientation of the crossing, which is good for limiting the crossing distance for pedestrians, and also the offset sidewalk from the roadway, which helps with pedestrians with vision impairments find the crosswalk location and line up for the crossing appropriately. The city of Wilmington, North Carolina has taken this drawing and added the option of raised crosswalks. Here's another example. This is from the Florida DOT. We don't see an emphasis here on the sharper angle with the cross street, but you do see how they've expanded the channelizing island with striping to narrow the turning path to try to slow down the smaller vehicles while providing the adequate width of pavement for the larger design vehicles. Again, we see the perpendicular orientation of the crossing and the turning roadway. Here we have longitudinal markings supplementing the transverse markings for the turning roadway crossing only. And here's an example of that implemented in Florida, as I mentioned. A concept that kind of flips the script a little bit on the striping is the City of Ottawa, Canada smart channel design, where they take, instead of increasing the channelizing island to narrow the turning path for vehicles, they've added striping on the outside of the turning roadway to narrow that pathway. So they've narrowed the pathway for smaller vehicles while providing the adequate pavement width for the larger design vehicles that you see in the top left. Again, we have the perpendicular crossing more towards the middle of the channelizing island. One thing to point out here is with the striping on the outside of the turning roadway, in addition to narrowing the turning path for smaller vehicles, we help achieve the higher angle of entry with the cross street to put that pedestrian crossing, like I said, more in the direct line of sight of the approaching motorist, as well as to reduce the amount of head turning required by the motorist as they spot gaps in oncoming traffic. Here's an example implementation of the smart channel concept in Ottawa. So from the findings of the literature review and looking at some examples from around the world in terms of the different types of treatments for these facilities, as I mentioned, we held a couple of focus group meetings where we brought in some TxDOT representatives in addition to those on the monitoring committee. We had 9 total TxDOT attendees, again including design personnel and field personnel, to discuss the findings and come up with ideas for implementing guidelines for the different design elements that I had identified earlier. We also got input on some other elements to consider, such as placement of design, drainage features and that sort of thing. With respect to the guidelines that have been developed to date, we've divided them. As I mentioned, the goal was for them to be in a format that could be implemented into the TxDOT roadway design manual. So we divided the guidelines into different facility types for urban, suburban, and rural roadway facilities. Kind of going through the different design elements and the recommendations briefly, we provided information on recommending the higher angle of entry with the cross street, providing the curb radius adequate for the larger design vehicle while narrowing the turning pathway with striping for smaller vehicles to help limit the turning speeds through these roadways, providing adequate pedestrian refuge with the channelizing island. A lot of this recommendation goes back to some of the other input in the roadway design manual currently. With respect to auxiliary lanes, we largely defaulted to input from the roadway design manual on that, where recommendations are provided with respect to deceleration lanes and acceleration lanes, and more or less recommending not to use acceleration lanes in urban and suburban settings where you don't necessarily want high-speed turns and you're more likely to have pedestrians crossing the roadway. We added some sections on drainage considerations for new and future construction to try to avoid conflict with pedestrian facilities and walkways. Supplemental to that, similar concerns with pole and sign placement, so making sure we avoid those pedestrian walkways. With respect to the crosswalk orientation, we went with the recommendations for putting that crosswalk in the middle of the turning roadway and aligning it perpendicular to the turning roadway to limit the pedestrian crossing distance. With respect to the markings themselves, we recommended using ladder markings, so the combination of transverse and longitudinal striping, while providing the option to use transverse striping only. And the intersection traffic control and bike lanes, we largely deferred to current guidance provided in the TMU-TCD. These drawings provide some examples of the draft standard drawings to date for these facilities. You see the drawing on the left with the deceleration lane and the one on the right without the deceleration lane. You'll notice a lot of similarities here to the smart channel concept. We've added the longitudinal striping again as a recommendation for the crossing within the turning roadway only. And we're attempting to achieve the benefits of narrowing the turning path for turning smaller vehicles, as well as placing that crosswalk more in the line of sight of approaching motorists here. Supplemental to those drawings, we have sort of a layout for the pedestrian pathway through the channelizing island. We were looking at some of the benefits of either the cut-through concept or the raised walkway. So the research shows that the cut-through pathway is recommended for pedestrians with disabilities. It helps them with wayfinding and getting through those islands. The concern is, though, that they can collect debris or water, and that is something that we want to avoid. So one of our TxDOT representatives came up with sort of a hybrid concept to raise the walkway to about 2 inches below the top of curb elevation, so we achieve the raised pathway to get away from some of the drainage issues and debris collection. But we're also providing a channelizing pathway as well to help with wayfinding for those with disabilities. Another concern that was brought up from the focus group meetings, in addition to the pedestrian pathway through the channelizing island, was the treatment of existing facilities and coming up with mitigation measures for issues identified in the field at these locations. This includes absence of adequate pedestrian refuge at these locations, non-compliance of yielding at the crossing on behalf of approaching motorists, or non-compliance of the crossing location by pedestrians, We looked at mitigation measures for excessive or high turning speeds, as well as low visibility of the crossing location itself, and then excessive head turning on behalf of the motorists as they look for gaps in oncoming traffic. We developed treatments for these issues that are consistent with those provided as recommendations for new construction. So real quickly, just to summarize, we developed these guidelines to establish a balance between mobility and safety for pedestrians at the crossing. And some of our future research recommendations are to look at this in implementation and evaluate it. Also looking at those thresholds in more detail for implementing supplemental treatments for the crossing location. I represent one person of a large team, including those from TxDOT. We received a lot of valuable feedback from them and had a great participation on their part in terms of helping with development of the design guidelines. We've also had design division, traffic division, and ped and bike coordinators have a chance to review these up to this point. So